This is the 5-minute check for the 5.1 to 5.4 test. Number 1 says name the quadrant in which each point lies. On A we have negative 3, 2. Well, if we were to draw a coordinate plane, we would see that when we plot this point, negative 3, 2, it would be located somewhere right over in here. So that would be where point negative 3, 2 is located. We said that the top right quadrant is quadrant 1, the top left quadrant is quadrant 2, the bottom left quadrant is quadrant 3, and the bottom right quadrant is quadrant 4. With that being said, on A, our point is going to be located in quadrant 2. On number 2, it says to name the quadrant in which the x values are greater than 0 and where the y values are less than 0. So this is always confusing to some people, but let's just come up with an example of a point where the x value is greater than 0. That means that the x has to be positive. So let's say positive 2. Okay, so then the y has to be less than 0. That means the y needs to be negative. So just pick any negative number, negative 4. And now let's see where that point is located. Well, 2, negative 4 would be down here somewhere. So that would be in quadrant 4. The other way that you can think about this is to just label the x-axis and y-axis and then go from there. Well, we know that when we go to the right on the x-axis, these are where the positive values are located, and if we move to the left, that's where the negative values are located. If we move up on the y-axis, that's where the positive values are located, and if we move down on the y-axis, that's where the negative values are located. So anything that's positive or greater than 0, that means we're going to go to the right on the x-axis, and everything that's less than 0 on the y-axis is going to be down. So we need to go to the right and down, which again leads us to quadrant 4. On number 2, it says express this chart as a relation, then identify its domain and range. So when we write a relation, we know that we're going to put all of our, first of all, we need to have some ordered pairs, and we need to put those inside brackets. So I would write it like this, and since we see 1, 2, 3, 4, 5 pairs of x's and y's, then we're going to have 5 ordered pairs inside those brackets. 1, 2, 3, 4, and 5. Alright, so at that point, I'm just going to list our x value with our y value. So our x coordinate is 0 and our y coordinate is 6. Our x coordinate is 1 and our y coordinate is 0. Our x coordinate is negative 4 and our y coordinate is 6. Our x coordinate is positive 4, our y coordinate is 0, and then our x coordinate is 3 and our y coordinate is 7. So our x and our y coordinates need to be listed in parentheses with a comma, just as we would write an ordered pair. Then it says to identify the domain. Well, the domain we said are going to be all of the x values. So when we see domain, we need to think the x's. And we are going to put these in brackets as well. And one thing that we need to remember about the domain and range when we're listing those, we are not going to repeat any values. If any x's appear more than once, then we'll simply list those one time. So we'll look at the x's and we'll see 0, 1, negative 4, positive 4, and 3. So none of those repeat, so I'm just going to list them all. 0, 1, negative 4, positive 4, and 3. And then for the range, we said the range is just the y values in our relation. So we need to analyze the list of y values. If any of them appear more than once, then we'll just list them one time. So we see 6, 0, 6, 0, 7. So since the 6's appear twice, and since the 0's appear twice, we're just going to list those one time. So we have 6, we have 0, and 7. So 6, 0, 7. You will need to get used to seeing this listed when we list the domain and range in numerical order from least to greatest. So we would see negative 4, 0, 1, 3, 4. And then for the range, we would have 0, 6, 7. On number 3, the directions say solve this equation for m. That means we want to get m by itself. So our first step is to subtract 3k from the left and subtract 3k from the right. Once we've done that, the 3k's cancel, and we end up with negative m on the left. On the right-hand side, these are not like terms, so we can't subtract them. I'm just going to write that. We could say 5 minus 3k, but I want to start putting the variable term in front, so I'm going to write that as negative 3k plus 5. At this point, we know what negative m is, but we want to know what positive m is. So we can think of this as negative 1m. So I'm going to divide the left by negative 1, and I'm going to divide every term on the right by negative 1 as well. So once we've done that, the negative 1 divided by itself cancels, just giving us m. And then on the right-hand side, negative 3 divided by negative 1 is positive 3, so 3k. And then 5 divided by negative 1 is negative 5. So instead of having plus 5, now we have minus 5. Again, since we have negative 5, I'm just going to write that as minus 5. Looking at number 4, the question is, which equation is linear? Linear equations have, we know, 3 things about them. First, no exponents other than 1. No exponents other than 1. Second, we know that x and y can't be multiplied. X and y can't be multiplied. And the third thing we said is no variables in the denominator. No variables in the denominator. So on number 1, is this a linear equation? Well, we see an exponent of 2. That means that a is nonlinear. It's nonlinear again because we see an exponent of 2, and this wouldn't create a straight line when we graph it. On B, we see 5 equals x times y. Since x and y are multiplied, then B is going to be nonlinear as well. But on C, we see exponents of only 1 with the x's and the y's. The x and y are just being added, they're not multiplied, and there are no variables in the denominator of a fraction. So our answer there is just going to be C. C is the only one that is going to be nonlinear. Number 5, it says, which ordered pairs are solutions for the equation y equals 2x minus 1? Well, solutions of a linear equation make the equation true, and that's when we substitute in the x coordinate for x and we substitute in the y coordinate for y. What we need to know on these is there can be more than one solution. We said earlier that there is an infinite number of solutions. What I'm saying is, out of these choices, A, B, and C, all 3 of them could be solutions, or none of them could be solutions, or 1 of them could be solutions, or 2 of them could be solutions. So we need to try A, B, and C. We can't just go until we find one that works and then exclude the other 2. So 0, 5, when we take y equals 2x minus 1, we need to take the x out and put in 0, so 2 times 0 minus 1, and we need to take the y out and substitute in 5. We want to see if that makes the equation true. Well, on the left, we just have 5. On the right, when we simplify using the order of operations, we end up with 0 minus 1, which is negative 1, so 5 equals negative 1. Well, that's not true, so A is not a solution. We'll do the same thing for B, though. We have y equals 2x minus 1, so we'll put the 3 in for y, and we'll put the 2 in for x. So 2 times 2 minus 1, and see if that works. 3 equals 4 minus 1. Well, is that true? Yeah, we get 3 equals 3, so we know that that works out. So B is a solution to that equation. And then we'll try C. Take the original equation, y equals 2x minus 1, and substitute in the x value and the y value. Y is negative 3. Our x needs to be 2 times negative 1, because our x value is negative 1. So then when we simplify, we get negative 3 equals negative 2 minus 1. Simplify the right side, and we get negative 3. So negative 3 equals negative 3. Is that a true statement? It is. So that means that solutions B, or the ordered pairs on B and C, are solutions to number 5. And let's look at number 6. It says, graph this linear equation. Use the domain negative 1, 0, 1, and 2. So there is a 4-step process that we've talked about using to graph a linear equation. First of all, we need to solve the equation for y. Second of all, we need to make a table of values. Third of all, we need to plot the points that we find as our solutions. And fourth, we want to draw a line through those points that we get. So first of all, we need to see that this is a linear equation. It meets the definition that we talked about on the previous problems on number 4. So what we need to do first is to solve the equation for y. So we need to subtract 2x from both sides. Once we've done that, the 2x's on the left cancel, and we're left just with 3y. On the right-hand side, 6 minus 2x, well, we can't subtract those two, so I'm just going to write that instead of 6 minus 2x, I'm going to write that as negative 2x plus 6. At that point, if we're trying to isolate y, we need to divide the left by 3, and we need to divide everything on the right by 3. So the 3 divided by 3 gives us 1, so just 1y. And then on the right-hand side, we can't really simplify 2 over 3, but we can bring the negative 2/3 out in front and write it like this, and that would help us get it in the form y equals mx plus b. And then 6 divided by 3 gives us 2, so plus 2. Okay, so that's the first step. Solve the equation for y. Then we need to make a table of values. That's where we choose some x values or domain values to put into our equation, and then we want to see what we get for our y value. So it tells us in the instructions we need to use these domain values. So that we do want to do that on the test if you're told which ones to use. So I'm going to put in -1, 0, 1, and 2. We're going to substitute those domain values in and see what we get for our range value. So we need to evaluate the right-hand side of this equation 4 times. So first thing I'm going to do is to take -1 out and put it in for x. So we're going to do y equals negative 2/3 times 1 plus 2 and see what we get. Well, it's going to give us negative 2/3 plus 2, which would be 2 which would be 1.3. When we simplify that, we get 1.3 repeating. I'm just going to write that as 1.3. So we get some kind of strange numbers, but we'll just estimate when we're graphing our solutions. The second thing we need to do is to take 0 and put it in place of x. So I'm going to write y equals negative 2/3 times 0 plus 2 and see what we get. Well, this gives us 0. 0 plus 2 is 2. So when we substitute in 0 and then simplify the right-hand side, then we're going to come up with 2. Then we need to take 1, our next x value, and put it in place of x and see what we get. So we're going to end up with y equals negative 2/3 x. Oops, sorry. Y equals negative 2/3 times 1 plus 2. When we simplify this, we get negative 2/3 plus 2, which would give us 1.3. So 1.3, actually 1.3 repeating, and then I just realized I messed up on the earlier problem. So this should have been -1 instead of +1, which is going to change our answer. That's going to give us 2/3 plus 2, so that's going to give us 2.3 repeating. So let's fix that at the top. And then finally, we need to substitute in 2. So we're going to take that equation one more time. Y equals negative 2/3 times 2 plus 2 and evaluate the right-hand side. So that would give us negative 0.6 plus 2, which is going to give us, oh sorry, I'm messing up again. We would get negative 1.3 plus 2 would give us 0.7, so somewhere around 0.7. All right, so that's the second step, is we need to get a table of values. Then we need to plot those points on the coordinate plane. -1, 2.3 would be located about 1/3 of the way between 2 and 3. Then we would plot 0, 2, which is going to be located right up here. Then we need to plot 1, 1.3. And then we need to plot 2, 0.7, which would be located right here. So we just kind of estimated with those points, but we're going to see that these are going to form a straight line. So our fourth and final step is to draw a line through those dots to represent the entire solution, all of the solutions, and not just the 4 solutions that we came up with. So our graph should come out looking something like that once we have gotten those 4 solutions. Again, the reason that we're using 4 solutions, well, first of all, it told us in the instructions to, but second of all, we need to be sure that we're using multiple solutions or multiple domain values and getting a lot of different range values to see if we mess up. If we got two points that formed a line and then we got a third that was out away from the line somewhere, then we know we messed up somewhere, so we can go back and check our answer. It's just a way of checking yourself. Get as many ordered pairs as possible to where if you mess up, one of them won't fall in line and you can tell that you messed up. And then number 7 looks like this. What are the solutions for this equation? Well, this is one of those absolute value equations where the first step we said we always need to take is to isolate the part inside the absolute value bars. That means if there's anything on the outside such as a 2 that's being multiplied by a 2, then we would need to divide by 2 to get rid of that 2. But in this case, on number 7, the part inside the absolute value bars is already isolated. So we said the second thing we need to do is to look to the number on the right. See what kind of number is over there. If it's a positive number, then we know that we're going to set up 2 equations. If it's a negative number, then in this case we would have no solution. But if it was an inequality, then it would either be no solution or all real numbers. So we have a positive number, so we're going to set up 2 equations. We know that this expression inside the absolute value bars, since we're taking the absolute value of it, the value of this expression can either be positive 5, because the absolute value of positive 5 is 5, or it can be negative 5, because the absolute value of negative 5 is also 5. So we'll set up 2 equations. 2x minus 1 equals 5, and we said that 2x minus 1 could also equal negative 5. At that point, we just need to solve those 2 equations. Add 1 to both sides. And when we've done that, the 1's cancel, and we end up with 2x equals 6. Divide the left by 2 and the right by 2. The 2's cancel, and we get x equals 3. So one solution is 3, and then if we solve the second equation, we're going to end up with 2x equals negative 4. Divide the left and the right by 2. The 2's cancel, and x equals negative 2. So these are our 2 solutions. If the instructions on the test told you to graph, then all we would do is to draw a number line, and we would label our solutions negative 2 and 3 and put a dot on each of those to show the solution. So our solutions would be 3 and negative 2. We would probably see that as a solution set of negative 2 comma 3. That means that both of these make the equation true. Again, you can check this, you can check these solutions just like with any other equation by taking our solution and substituting it back into the equation for x and seeing if it makes sense. 2 times 3 minus 1, the absolute value of that, equals 5. So let's see, 2 times 3 minus 1 equals 5. So this would be the absolute value of 6 minus 1, which is 5. Absolute value of 5 equals 5. Well, yeah, the absolute value of 5 is 5, so 5 equals 5. What if we put in negative 2 for x instead? Absolute value of 2 times negative 2 minus 1 equals 5, and then we'll simplify what's inside the absolute value bars. 2 times negative 2 is negative 2, or negative 4. Negative 4 minus 1 is negative 5. Is the absolute value of negative 5 equal to 5? Well, the absolute value of negative 5 is positive 5. Is 5 equal to 5? Yes. So both of our solutions worked out on that problem. I hope this helps.